Polars SQLContext and Lazy DataFrames. Laziness and SQLContext are two very important features of Polars. These features takes Polars to the next level. Laziness allows Polars to read larger than memory files. SQLContext allows us to write queries using SQL. In this lesson, we will learn how to use laziness features of Polars and how to use SQL context for querying using SQL. So, let's begin. Let's first create a data frame from the dictionary result as shown in the code snippet above. Here, Polars DataFrame will create an in-memory data frame. Let's check the data type of DF. As we can see, DF is Polars DataFrame type. If we replace DataFrame with LazyFrame, we will get a LazyFrame from the same data. As we can see, LF is Polars LazyFrame type of object. In short, pl.dataframe creates a data frame and pl.LazyFrame creates a LazyFrame. Now suppose we have a very large CSV file. In Polars, we may create a data frame from this file using read_CSV function. The problem with read_CSV function is that the file size should be less than the available memory of the computer system, otherwise it will fail. Let's consider the following code snippet. The read_CSV function reads the file from the mentioned path and creates a data frame. As we can see, we have successfully read the payment.csv file as it fits into the available memory. The data frame has 9.8 million records and 11 columns. Now imagine that the payment.csv file is so huge that it does not fit into available memory. In this case, we are bound to use the scan_csv function. Here is an example of it. Here LF is a LazyFrame. That is, the whole file is not loaded into the memory. Only the required portion of the file will be loaded into the memory when required. Now let's look at the following examples. LF.fetch5 will load only 5 records into the memory. We may also select the required fields before fetching the records. Now the load size is less than the previous one. We may also create a LazyFrame by combining the scan_csv, select, and fetch in one statement as being shown here. We may also filter out the desired records as being shown here. Here the records for only West Zone will be selected. Now let's see how we can make a LazyFrame into a data frame using .collect. As we can see, now LF is a data frame. We may use this feature when the size of the data is small and it will not create memory burden. We may also convert a data frame into LazyFrame using .lazy as being shown here. So, that was a brief introduction to Polars LazyFrame. Now let's come to our next topic, SQL Context. As I have said earlier, SQL Context allows us to query a data frame using structured query language. Let's consider this example. Here res is a dictionary object. Let's create a Polars data frame from this dictionary. Here, df is a Polars data frame. Now let's see how we can query this data frame using SQL. Polars.SQLContext creates a SQL context object. The register method is used to register a data frame as a table. Here df is our data frame and result behaves like a table. Now we may use the execute method of the SQL context object to execute SQL commands. Here is an example. As we can see, the execute method returns a LazyFrame. Now we may use the fetch or collect methods to access the records from the registered data frame. We may also create SQL context object and register a data frame in one go as being shown here. Now we know how to use SQL for querying a Polars data frame. Now we will learn how to use SQL context in different ways in the rest of the lesson. Just follow me along while I code. Please note that although Polars supports SQL, Polars itself recommends the use of expression syntax for more readable and expressive codes. Polars translates SQL queries into expressions before execution. That's all for today's lesson. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.